All right, so today we're going to look at section 2.2, and actually that's the section we're going to look at all week. It's the only section. We're just going to do a little bit of it each day. So we'll spend 3 days on it. Should be done everything by Wednesday. And then, as I said, Thursday will be a review day. All right, so I'm going to start out with this, this diagram. Okay, so what I've drawn here on the board is what's called a unit circle. What makes it a unit circle is we have a radius of 1. That's all unit circle means. It just means the circle with a radius of 1. And then going around the circle, I've labeled some different angles. Okay, on the right, I've labeled 0, and then starting to rotate counterclockwise, 90s at the top, 180 on the left, 270 at the bottom. Okay, so any questions on that? That's all so far. So the whole point, kind of the purpose of unit circle trig is to figure out a coordinate. You need an x value and you need a y value. And if you remember some of the formulas I just showed you, they all had y and x in them. Well, that's because the y and x come from a coordinate. So that's what we're going to try to figure out. So that's what this is saying right here. Every angle can be represented as a coordinate. Now, when I say every angle, we're only going to work with certain angles. Okay? This approach to trigonometry using a unit circle is really only good for angles that are multiples of 30 and 45 degrees. Okay? So only angles that are multiples of 30 and 45 degrees. That's what I mean when I say every angle. So if you're thinking, well, why? Why can't you do it for an angle of like 10 degrees or 20 degrees? Well, you can, but the coordinates start to get kind of messy, and these are more common. Okay? Angles like 45, 90, 30, 60, 120. Those come up more, and that's why we only use those. All right, so let's see if we can just label the 4 coordinates that I have here. So this is the origin. Okay, that's not a point on the circle. Okay, we want to focus on the 4 that are on the circle. 0, 90, 180, and 270. Okay, let's start with 0. So if the radius of the circle is 1 unit, to get from the origin to the point for 0 degrees, how many units do you have to move from the origin to get to 0 degrees? Yeah, Corey? 1 unit. And which way? 1 unit?
To the right.
To the right. So what's the coordinate if you just go 1 unit right?
1, 0.
1, 0. Exactly. So now you know the x value and you know the y value for 0 degrees. The coordinate is 1, 0. And even if you don't memorize it, you don't really have to. If you can just draw the picture and think about which way you're moving, that'll kind of help you to see it. Okay? As long as you can remember where 0, 90, 180, and 270 are. Okay, but that's the normal way. We always label a circle. All right, let's look at 90. All right, so again, every one of these coordinates they're all 1 unit from the origin. It's just a different direction now. Anyone think they could give me the coordinate for 90? Yeah, go ahead.
1, 1.
So 1, 1 would be right 1, up 1. It would be kind of like over there.
Oh, 0, 1.
0, 1. Yep. So we don't go left and right, we just go up 1. So there's the coordinate for 90 degrees. And that never changes. It's always 0, 1 for the whole week. Okay. So that's 90. Let's do 180. How about Joe? You think you give me the coordinate for 180?
-1, 0.
Yep. -1, 0. And then the last one, 270, is 0, -1. So those are the easiest coordinates that we'll do all week. Okay. What makes those coordinates a little easier to work with? If you look at them, what do they all have in them?
1.
They all have either a 1 or a negative 1, yep, and
0.
a 0. They're all on the axes. All right. Anytime a coordinate is on an axis, one of the x or y values is always 0. 0 is just an easier number to work with. When we do something like this, which we'll look at tomorrow, that's a 45-degree angle. Well, we're not going to have a 0 in that coordinate because you're going to go right and you're going to go up. Okay. None of the coordinates we look at today end up doing that. Yep, Joe?
Oh, nothing, never mind. You answered my question.
All right. So we'll look more at other angles tomorrow. So when we're looking at angles, remember that there's two ways you can write an angle. You can write it positive, you can write it negative. Generally, we like it positive. So if you rotate counterclockwise, that's positive. If you rotate clockwise, that's negative. Okay. And I'll bring up something I showed you last week. It's kind of a little thing on the web where I can just drag the terminal side of an angle and just show you different directions. Okay, so let's take a look at something that'll kind of allow me to demonstrate what I'm showing you right here. So this program doesn't give me coordinates. Okay, all it does is allow me to drag the terminal side in different directions. But you can see if I go counterclockwise, the angle's positive. And then if I go clockwise, now I'm getting into negatives. And that's important because every angle can be named in two different ways. If I wanted to talk about this point right here, negative 90. Well, when I drew the unit circle, what was the angle that I labeled that went straight down? I didn't label it negative 90.
270.
I labeled it as 270. It's the same thing. Negative 90, positive 270. If you're thinking in terms of trig, they're the same number. They're exactly the same. And just to kind of show you an example, let's say you took the sine of negative 90. Okay, you don't have to worry about what this is doing. I just want you to see the answer. Okay, the sine of negative 90 is negative 1. The sine of 270 is negative 1. Okay, so for purposes of trig, those two numbers will give you exactly the same answer because they're in the same spot on the circle. Okay. Any question on that? Yeah.
If it goes around more than once, would it be the same number or would it be more?
Yeah, so you could also do 630. Again, for purposes of trig, 630 is exactly the same as the other two we just typed in. Yep. We generally like to use a positive one, but not that big. We generally like to use numbers between 0 and 360. Okay. Yeah, it doesn't mean you can't go negative, doesn't mean you can't go more than 360, but between 0 and 360 are the easiest ones to kind of think about in our head. So let's look at the example that Joe just mentioned. He mentioned, well, can you go more? Going more than 360. You can, but if you ever get an angle that's more than 360, we want a way to make it smaller. Okay, more manageable. Well, we already know that 630 is the same as 270. Okay, we know that just by looking at it. If I go like this, start at 630, and go around one time, and then stop. What did I just subtract from 630?
370.
3 what?
360.
360. I just subtracted one revolution, which is 360 degrees. And you can do that anytime you have an angle that's bigger than 360 to make it smaller. Keep subtracting 360 until you finally get an angle between 0 and 360. If you subtract too many times, then you'll go negative. We don't want to go negative. So you want to make sure your angle is greater than or equal to 0, but you also want it less than 360. So between 0 and 360. Right, so if you had a problem, something like I said to you to do some sort of trig with the angle 1,350. Okay, it's a big angle, right? In your head, if I give you that, it's kind of hard to visualize where it would be. But if you take 1,350 and subtract 360, you're going to keep making it smaller until we finally get it to something more manageable. And you're not messing up the answer. You're always allowed to add or subtract 360, and it won't mess up the problem at all. So keep doing it. And now I say, okay, it's the same as 270. I know where 270 is. I know where it is from this picture right here. All right, so that's kind of the idea. Anytime you get a big angle, we want to make it small enough that we can work with it. And just bring back the other page. We can also do the reverse. Let's say you get an angle that's negative. What do you think you can do to a negative angle to make it positive? Yeah.
You add 360.
You add 360. Okay, how many times do you add it? Well, keep adding it until you get an angle between 0 and 360. If you add 360 too many times, then it's going to get too big. So we have kind of a zone we're looking for. 0 to 360. Okay, so let me show you one that's negative, and then we can add 360. So let's say I gave you an angle like this. Negative 1,035. Okay? If somebody said that to me, it's kind of big. In my head, I have a hard time thinking about it. So if I took 1,035, and I'm going to add 360. What that does is it brings it back one time, okay, to negative 675. I'm going to add it again. I'm at negative 315. Right about there. It's still negative. So you know what? I'm going to do it one more time. And I say, oh, okay. That angle that I started with is exactly the same as 45. And to me, 45 degrees, I can visualize 45 degrees in my head. I know it's halfway between 0 and 90. But the one I started with, negative 1,000 something, it was too negative to kind of think about. Any questions on that idea? It's adding or subtracting 360 to make it something a little more manageable for us. All right, so now that we have a coordinate, and the only four that we've done so far are 0, 90, 180, 270. We can take that coordinate and plug it into a formula. So the 6 definitions that I'm about to give you are all based on knowing the coordinate. If you can't figure out the coordinate, or you don't remember the coordinate, you can't do unit circle trig. Okay, you have to have a coordinate. And at first, it might be a little tricky to remember, like, oh, which one is this, or which one is cosine, which one is sine. But after you work with them, it's not too bad. So this is the first time we've seen the trig functions in this class. As I said earlier, if you've done SOHCAHTOA, you've seen these before. Let's look at them. So, if I ask you a question about the sine of an angle, okay, you would plug in an angle right here, like 0, 90, 180, 270. Okay, so you'd plug in something right there. And I asked you the sine of that angle. What I want you to do is just tell me the y value of the coordinate for the angle. That's it. There's no calculation, nothing you have to do. Just fill in the y value. If I ask you for the cosine of that angle, okay, cosine of 0, cosine of 90, first thing you got to do, okay, what's the coordinate? Write that down. And then if I want to know the cosine, I want to know specifically the x value. So there's no arithmetic there. With tangent, yeah, there's a little bit of arithmetic. You have to divide. Okay, you take the y value and you divide by the x value. And those are the three most basic trig functions we have. Pretty much any calculator that's scientific. This is not scientific right here. But if I make it scientific, sine, cosine, tangent. It's got those three buttons right there. Okay, if you've got a graphing calculator, sine, cosine, tangent. Okay, right on the calculator. We'll talk about using the calculator a little bit later on the week, but we're not going to need calculator today. All right, these are also abbreviated. So from now on, when I write sine, you'll see SIN, so sine, cosine, tangent. And those are the same abbreviations you see on a calculator. They're all 3 letters. Okay, the next 3 trig functions, you don't see buttons for these on the calculator. Doesn't mean you can't do the secant on the calculator or the cosecant or any of them. You can. There is a way to do it. Not something we're going to look at right now. All right. Now, these 3 on the right are really very similar to the 3 on the left. So if you're thinking, well, now I got to memorize double the formulas. I got to memorize 6 instead of 3. Not really. If you know the 3 on the left, you automatically know the 3 on the right. And I'll show you how. So Skylar, the only fraction I have right now is the tangent, y over x. But if I wanted to make sine into a fraction, what number could I put? It's like invisible underneath if I wanted. A 1. I could put a 1. And we can put it over 1. And the way you get the 3 trig functions on the right is all you do is take the ones on the left and flip them. So the cosecant, it's not y, it's 1 over y. And k, using kind of the same reasoning, do you think you could tell me what the secant would be?
1 over x.
Yep, it's 1 over x. Good. And Christian, how about the cotangent?
I actually don't.
All right, do you see how we got the 2 above it?
Yeah.
From that, do exactly the same thing. Follow the same pattern as the 2 above it.
Should we divide by 1 over x divided by 1?
Well, it's already a fraction, so you don't need to even put the 1s in there.
Oh, x over y.
Just flip it the way it is, just x over y. Yep, you just flip it. And the abbreviations, most of them use the first 3 letters. If you notice, that was the pattern. So cotangent is COT. Secant is SEC. How about cosecant? Could I use the first 3 letters? No, why not?
Because cosine would have the same thing.
Yeah, cosine already used the first 3. So what they do for cosecant is they just use the syllables. Cosecant. Cosecant. CSC. All right. So if you can remember, sine is y, cosine is x, tangent is y over x. That's the first 3, and then you flip them to get the second 3. 1 over y, 1 over x, x over y. Any question on those formulas? And again, if you've done SOHCAHTOA, this is the same thing. It's pretty much the same thing. It's like kind of measuring this table in feet and then measuring in inches. It's just 2 ways of measuring exactly the same thing. And next week I'll show you that this is the same thing as like opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Just calling it a different thing, that's all. All right, so now the 4 angles that we've worked with so far. Okay, the 0, 90, 180, and 270, they have a special name. Since those angles are all on the axes, and the axes divide the plane into 4 quadrants, those are called your quadrantal angles. So technically 0, 90, 180, and 270, they're not in any of the quadrants. They're all on an axis. And those are the only angles we know how to find the coordinates for, because those are easy. 0, 1, 0, negative 1, 1, 0, things like that. So those 4 angles are called the quadrantal angles. All right, so now how do we actually do unit circle trig? Okay, you know coordinates, you know formulas, so what do? Well, basically you just plug the coordinate into the formula. That's it. So the first step is to find the coordinate. After you've worked with 0, 90, 180, and 270 a lot, you'll probably have it memorized. Or you can look up, you can visualize a circle in your head real quick and be like, oh yeah, 90, that's to the right. If I go right 1 unit, 1 comma 0. You kind of can visualize it. But you can always draw it too. So that's step 1. Find the coordinate. Sometimes they'll give you the coordinate in the problem. Okay, and don't be freaked out if they give you a coordinate that's not a 1 comma 0 or 0 comma 1. You might get a coordinate that looks like this. Negative 1/2 comma square root 3 over 2. We don't have to know how to get that coordinate right now. Okay, they're giving it to you. What that means is this is not the coordinate for 0, 90, 180, or 270. It's another angle that we're going to study later on. How do you get the coordinate? Don't worry about it right now. I'll show you how to get it later. For now, they're just giving you the coordinate. Okay, so sometimes you're going to be given the point. And then the second step is basically plug in your point. Take the x and y value that you just got from step 1 and plug it into one of the 6 definitions we just went through. Now, if you're wondering, well, which one do I plug it into? There's 6 of them. Well, depends on what the question asks for. If the question asks for sine, plug it into sine. If the question asks for the tangent, plug into tangent. Okay. The way it's going to be set up on the test is I'm going to ask you 1 trig function per problem. I'll say find the cosine, okay, or find the secant. The way we're going to practice it in class is we're going to do all 6. So I'll give you a problem and I'll say find all 6. So we practice doing each one of them. Okay, any questions on the 2 steps? So, the first problem, they're giving us a coordinate. Where is the coordinate? Well, it's somewhere on the unit circle. Where on the circle? Don't worry about it. It doesn't matter where it is. But the point is, they gave you a coordinate. So you have an x value, and you have a y value.
Wait, I didn't get to finish writing down those 2.
The 2 steps here? I mean, you can really shorten that up a lot. Step 1 is determine the coordinate. Step 2 is plug into one of the 6 formulas. Or you can write the whole thing out. Okay, so the point that I circled is a point somewhere on the unit circle. Okay, and if you're like, well, how can we do unit circle trig if we don't even know the angle? All we know is a coordinate. You don't need the angle. All you need is a coordinate to do this whole thing. Okay, and the example I usually give is, it's kind of like if you met someone on the street and you didn't know their name, and someone said, can you describe the person? Sure. I can describe someone and say, yeah, they're wearing a blue shirt, they're wearing jeans, they have white sneakers, they have brown eyes, and I don't know their name at all. I don't need to know their name to describe the person. That's kind of what we're doing here. We don't need to know how big the angle is. We're going to describe 6 things about it. We're going to describe the sine, the cosine, the cosecant. It's kind of the same idea. You don't need to know how big the angle is. Okay, so we've got our coordinate. So let's start with sine. Okay, how about, can you remind me, what's the formula for sine?
Y over 1.
Yeah, it's just y. Yeah, you can say y over 1, but it's just y. So in this problem, if we look at it, Derek, what's my y value? Square root of 3 over 2. So the sine of some mystery angle, which again, we don't know what it is, we don't need to know what it is, but the sine of it is the square root of 3 over 2. By the end of the week, will you be able to know what angle we're talking about right now? Like, is it 100 degrees? Is it 150? Like, how big is it? Yeah, you'll be able to figure that out by the end of the week. But it's not necessary right now. Okay, cosine. So let's go to our cosine. How about Oscar? What's the formula for cosine?
X.
X. So we'll go back up, look at our x value. What's my x value here?
Negative 1 over 2.
Yep, negative 1 over 2. Hey, those are the easiest two because they're directly from the coordinate. The y, the x. Everything else is a calculation. Okay, maybe you have to flip something or divide something. So let's go through that. Justin, so now we're at tangent. What's my formula for tangent?
Y over X.
Y over x. So y is the square root of 3 over 2. X is negative a half. And we're going to divide them. So square root of 3 over 2 divided by negative a half. Now, when you have a fraction divided by a fraction, some people do it this way. They take the one that's in the bottom and they flip it and they make it multiplication. And then the 2's cancel. The way I usually do it is if I see a fraction over a fraction and the denominators are the same in each one, I just cross them out. They're just going to cancel no matter which way you do it. Okay. So the only thing I'm left with is the square root of 3 divided by negative 1. And that would be the exact same thing here. There's your negative. There's your square root of 3. Negative square root of 3. All right, so if you like to flip and multiply, that's fine too. As far as writing down decimals, you don't need to. You don't have to write decimals for anything we do. You always leave it as a square root. Or a fraction, like negative a half. Okay. Questions on the sine, cosine, or tan? All right. So Eric, earlier I said that if you know the 3 on the left, you automatically know the 3 on the right. Do you remember what I said you had to do to each one of the ones on the left to get the ones on the right?
You just put a 1 on top of the fraction.
Okay, so what are you really doing? There's a name for it.
Like the... I'm not sure.
You want to help out, Joe?
You just flip the fraction.
Just flip the fraction, right? Flip it. So if you want to know the cosecant, flip the sign. So it's 2 over the square root of 3. Now numerically, that is the answer. But if you left it like that, that's kind of like leaving a problem like this. You're not done. Okay? It's not as simple as it could be. Does anybody know what's wrong with cosecant? It's not the same thing that's what's wrong with that one. But yep.
You're not supposed to leave a square root on the bottom.
Yeah, we don't leave the square root on the bottom. It's just kind of something people just don't do, so we don't do it. And we talked a little bit last week about square roots. Does anyone remember how you fix that? So you don't have the square root in the bottom?
Something to do with exponents?
No, nothing with exponents. Sometimes, like when you're solving an equation and you want to get rid of a square root, you square. Something like that. And that has an exponent, but this won't have an exponent. Yep.
You want to multiply it by square root of 3 over square root of 3.
Yep. You want to multiply the top and the bottom by square root of 3 over square root of 3. So in the top, you get 2 square roots of 3. And in the bottom, excuse me, square root of 3 times square root of 3, that's the square root of 9. Well, that's just 3. So you can't get rid of the square root. But all we did was now put it in the top instead of the bottom. And that's okay. Any question on that one? Yes?
Why'd you do the square root of 3 over the square root of 3?
Because you always want to multiply the top and bottom by the same thing. So that's the first thing. And the way you get rid of the root is to multiply by whatever is right here. So you look at your fraction, whatever's in the bottom, if it's a square root, that's what you use to multiply. Okay, let's look at secant. So how about Christian? I've got negative a half. What do I do with that to get the secant?
It should be 2 over negative 1.
Yeah, and how did you get that? What did you do?
I just flipped it.
You just flip it. So it's just negative 2 over 1, which we can really just say negative 2. So not every time you flip something, you're going to get a fraction in the bottom. Depends if the original had a fraction in the top. Okay, this one didn't. Okay, and the cotangent. Well, we know we have to flip tangent. But right now, my tangent's not a fraction. So how about, Chris, what can I do to make that a fraction?
I really don't know.
Think about what can you do to make any number a fraction. Like if I wanted to make the number 3 a fraction. By?
3. Not a fraction.
Yeah, I want to make it a fraction, but you can't put 3 in the bottom.
1.
A 1, yeah, you can always put a 1 in the bottom of any fraction. So let's put a 1 in the bottom of that fraction. Now we've got something to flip. All right, so Eric, if I flip that, you don't have to tell me the final answer. Just tell me what I get when I flip it.
1 over square root of 3.
1 over the square root of 3, close.
Would it still be negative?
It's still negative. Yep. Okay. When you flip it, the negative doesn't go away. Now, the negative isn't a problem there. You can have a negative in a fraction, that's fine. It's just the square root. So that's what we need to fix. So Corey, what would I multiply by here to fix the square root of 3? Yep, just the square root of 3. If you're like, well, how come not the negative? The negative's not a problem. It's just having the square root. So in the top, you get square root of 3. And in the bottom, the square root of 3 times the square root of 3 is the square root of 9. But there's a negative in front. Square root of 9 is 3. Leave the negative in front. So negative 3. Now, if you're wondering, can I put the negative in the top? Sure. It doesn't matter where you put the negative in a fraction. Negative 3 over 2, that's exactly the same as 3 over negative 2. There's no difference there. Any questions on that? Yeah.
When you multiply the square root of 3 over the square root of 3, why didn't you do this negative square root of 3 over the negative square root of 3?
Because the negative isn't the problem, and if you put a negative divided by a negative, what happens? It just becomes positive and they just cancel out. So if you put a negative in the top and in the bottom, they would just cancel out anyway. So whatever you multiply by, it's always positive. Okay? And if there's a negative in the original somewhere, just remember to throw the negative in front when you write the final answer. Okay? So something like that would be 6 separate problems on a test. Okay, 1 for each thing I had circled. Any questions on that? All right, so those were our 6 trig functions. A lot of them that aren't quadrantal angles, in fact, all of them have square roots in them. The only ones that don't are 0, 90, 180, 270. Those are all nice coordinates. Okay, let's try this one. So find the 6 trig functions of square root 2 over 2, comma, square root 2 over 2. Now, again, I'm not telling you what the angle is. This is the coordinate that corresponds to some angle somewhere. But I bet someone can figure out what that angle is. The x and the y value are the same. So, could anybody think, if you had a circle, and they're both positive. So if you went right and up exactly the same amount on this circle, does anybody know what angle you would be at?
45.
Yep. You don't have to know it for today, but that is the coordinate for a 45-degree angle. It's right here. It's right and up. Tomorrow, I'll show you how to figure out that coordinate. But for today, they're giving you the coordinate for a 45-degree angle, so step 1 is done for you. X is root 2 over 2. Y is root 2 over 2. Right, so take a minute or two and see if you can figure out the 6 trig functions. And you might notice a lot of answers repeating here because x and y are the same. All right, so let's start to take a look and see what we got. All right, so we know the x value, we know the y value, they're the same. So Joe, what's my formula for sine? Just what letter?
X.
That's cosine.
Oh, Y.
Y. In this case, if you did mix them up, you'd be lucky. They're the same. You wouldn't get it wrong. But normally they're not the same. So yeah, sine is y, and y is root 2 over 2. So k, we just said the formula for cosine. That's my x. What's x in this case?
Square root of 2 over 2.
Yep, it's also square root of 2 over 2. Christian, what's my formula for tangent?
It's x over y.
X over y is cotangent.
Oh, I got it. It's y over x.
Again, in this case, that wouldn't make a difference because they're the same, but normally it would. So y over x. So we've got y, and we've got x. So all we're really doing is dividing two things that are the same. So Corey, if I divide two things that are the same, what do I get? They cancel out, and you get? So we're dividing y by x. 1. When you divide two things that are the same, you just get 1. Now that makes the cotangent quick. If you want to write that one down right away, the cotangent is 1. So if you flip 1 over 1, you get 1 over 1. Okay, and how about Skylar? What do I have to do to sine to get the cosecant?
You have to put 1 over or flip it.
Oh, well, it's already a fraction, so we don't even need to do the 1 over thing. I mean, you can, but it's already a fraction. So now let's do the second part of what you said, which is just flip it. If it's a fraction, just flip it. So 2 over the square root of 2. But Eric, what's wrong?
The square root on the bottom.
Square root on the bottom. And how do I fix it?
Do you make it negative? Or no, you flip it and then multiply.
And what do you multiply by? So we flipped it, we got that part. And we're going to multiply the top and the bottom by
2.
Not 2. Close. What do we?
Square root of 2.
Square root of 2. Okay, you always multiply by whatever's the square root in the bottom. Now, you get 2 times the square root of 2. You just go straight across. And in the bottom, the square root of 2 times the square root of 2 is the square root of 4, which is 2. Well, what happens there?
2's cancel out.
The 2's cancel out. Not the 2 under the root. You can only cancel out numbers that are outside the root. So we just get square root of 2. And that's one that after a while, whenever you see root 2 over 2, you know, oh, when you flip it, it's root 2. Okay? You might have to go through the steps a couple times, but eventually you'll probably just remember it's just root 2. How about the secant? What would the secant be? Same thing. How come?
It's the same exact problem.
Yeah.
Numbers.
It's the same problem we just did. The sine and the cosine are the same answer. So that means the secant and the cosecant are the same answer. Any question on that one? Right, let's take a look. Actually, that's just kind of the same. Does anyone feel like we need to do another one that's like the last two? Yeah. There's nothing different there. That's a little different. It says find the 6 trig functions of 90 degrees. All right. So what's different there? Yeah. They didn't give us the coordinate. That's the whole key. I don't care what the angle is. I don't even need the angle. All I need is the coordinate. So I've got to figure out the coordinate for 90 degrees. So one, you either memorize it, figure it out, or make a sketch, draw it, and just kind of see where it would be. So if I'm looking for 90, where's 90 on that circle? Joe?
On the very top on the y-axis.
Yep, it's at the top. And we know that it's 1 unit in every direction because this is a unit circle. So what does that mean the coordinate for 90 degrees is? 0, 1. You go up 1. Now you've got an x and a y value. Now this problem is just like the last two. Except the numbers don't have square roots. Okay, because we're dealing with a quadrantal angle. Okay, so let's start with 90, or sine. Oscar, what's the sine of 90 going to be?
1.
1. It's the y value. So the sine of 90 is 1. Mike, how about the cosine of 90? 0. It's the x value. And now the tangent is the y value divided by the x value. Y divided by x. What happens when you divide by 0? Yeah?
Isn't it undefined?
It's undefined. You cannot divide by 0. If you try to, the calculator says cannot divide by 0. Can't divide by 0. So that's undefined. So you just write undefined. All right. Now, take the ones that are on the left and flip them. So how about Derek? No, that's not a fraction, but we could make it a fraction by putting a what?
100.
Putting a 1 under it. So if you take 1 over 1 and flip it, what do you get? 1. When you flip 1, it stays 1. Okay. And Sam, let's look at 0. That's not a fraction. So we could make it a fraction by...
Divided by 1.
Yep, put a divide by 1 in the bottom. So when we flip 0 over 1, we get 1 over 0. And what did we just said 1 over 0 is undefined. So this is kind of showing you, if you flip 0, you get undefined. Well, if you flip undefined, that would bring you back to what number? 0. And if you're like, well, how come? Well, 1 over 0, when you flip it, is 0 divided by 1. If you want to take $0 and divide it to one person, give it to one person, they're going to get nothing. So, any questions on that? So when you're dealing with a quadrantal angle, the answer is always one of 4 numbers. 1, 0, -1, which we didn't have a negative in this problem, or undefined. Those are the only 4 answers you'll ever see when you're dealing with a quadrantal angle. When you're dealing with an angle that's not a quadrantal angle, you'll see other answers, like square roots of 2's and square roots of 3's. So it's 90. Let's try this one, except this time it's only asking for the first 3. So you're not going to have to flip it. I just want to know the sine, the cosine, and the tangent. Okay, so this one also has another little twist. It's kind of like the last problem, but there's one more step. What's different right here? Well, yeah, what does that mean? If they're giving us an angle that has a pi in it without a degree symbol. Yep.
Isn't it in radians?
It's in radians. Yep. It's in radians. So for me, I think most people, they don't think as well in radians. So we can take the radians. And does anyone remember what we multiply by to change it to degrees? Yep.
180.
180 divided by pi. That cancels. And I'm left with 3 times 180. So now, I'm working with the angle 540. Now, that's better because it's in degrees, but I still don't like that number. What do you think I don't like about 540? Yep.
It's over 360.
It's over 360. And at the beginning of class, we talked about something you could subtract from it to make it under 360. And then I think it'll be a lot easier to see where it is on the circle. Because right now, it's one of these 4 points. So what can I subtract from it? Yeah.
360.
Subtract 360. Now I can see it's 180. Where's 180 on the circle? Yeah. Yes, yeah.
On the left.
It's on the left. So it's left from the origin, 1 unit. What's the coordinate if you go left?
1, 0.
180.
0.
So 1, 0 would put you on the right. You want to go the other way.
Negative.
Negative 1, 0. Yep. Now we've got the x and the y value. Now we just fill them in. So my sine is going to be my y. My cosine is my x. And the tangent, the way I kind of look at it, is it's just dividing the number that's above by the one that's below. Y divided by x. So 0 divided by negative 1. Okay. And 0 divided by anything is always what?
0.
0, yes. Anyway, if you get confused, 0 divided, let's do it this way. A number divided by 0 spells no, means you can't do it. Number divided by 0, no, it's undefined. If you do it the other way, 0 divided by a number, on. Yeah.
I said you are on point.
You are on point, you are on track, keep doing what you're doing. So, it works better the other way. Number divided by 0, no. And that's it for that one. Okay, any questions on that one? Alright, so why don't you guys try this last one. Find the 6 trig functions of 11 pi over 2. Okay, very similar to the last one. It's in radians. So you might want to change to degrees first. And then once you change to degrees, you might get a number that's pretty big. So you may have to try to make that smaller. Okay, so let's take a look at this. Again, 11 pi over 2. Kind of hard to just look at that number and off the top of your head know where it is. But I bet if we change it to 0, 90, 180, or 270, you'll be able to tell where it is right away. So let's do that. So Joe, what do I multiply by?
180 over pi.
Yep, 180 over pi. Pi's cancel. If you want to reduce 2 into 180, you can reduce that first. Just don't start subtracting 360 yet until we finally reduce all that. So 11 times 90, that's going to give me 990. But even though it's degrees, that's still kind of big. So what can I subtract from it?
360.
Subtract 360. We might have to do it a couple times. Okay, probably twice. So you do it once, 630, twice, 270. Now, where's 270 degrees on the circle? The bottom. Much easier to tell now. And the coordinate is just 0, down 1. So 0, negative 1. Right. So Corey, what's my sine? Negative 1. Yep. Eric, what about my cosine?
Positive 1.
Well,
Oh, no,
it's
0.
the cosine, yeah, it's just the x value, so it's just your 0. And now tangent is y over x. So Chris, if I try to take -1 and divide by 0, what do I get?
Undefined.
Undefined. You can't divide by 0. Right? Now we take the 3 on the left, and Skylar, what do I do to the ones on the left to get the ones on the right? Flip them. So what do you get if you flip -1? -1. -1 and positive numbers are the only two you flip, and they stay the same. They don't change. Okay. So the next one, think of it as 0 divided by -1, or 0 divided by 1. And Oscar, what do I get when I flip 0?
You get 1 over 0.
1 over 0, which is undefined. You can't do that. So when you flip 0, you get undefined. When you flip undefined, you get 0. Right? So again, that would be 6 separate problems on the test. Any questions on that? Okay, so that's the first part of unit circle trig. Tomorrow we'll take a look at how those square roots of 3s and square roots of 2s, kind of where some of those were coming from. All right, so the homework tonight, it's on page 116. It's 11 to 27, just the odds, and number 22. Okay, you've got about a little over 15 minutes, so please use the time to try to get a little bit of that done. If you have your book, you can just use that. If not, you can pair up with someone if they have a book too and kind of work together. If you need to borrow a book, I have some you can also borrow.